Hello, I'm Sienna Bose, and welcome to my channel, Learningbuildslife. Today, we are going to talk about study of an element from the analysis of its electronic configuration, or EC. Today, I am going to mention two metals, potassium and calcium. Let us start with potassium. Potassium. K. First, its atomic number. It is 19. Now, EC. EC is 2A1 K L M N, which means there are 2 electrons in the K shell, 8 in the L shell, 8 in the M shell, and 1 in the N shell. Therefore, number of valence electrons is number of valence electrons, which means number of electrons in the outer shell, which in this case is the N shell. It has 1 electron. Therefore, period number is 4, since potassium has 4 shells. Now, group number. Group number is number of valence electrons since it is less than 3. This is a rule. If number of valence electrons is less than 3, then that determines the group number. 1. Now, valency. Valency is also number of valence electrons since it is less than 5. This is another rule. If number of valence electrons is less than 5, like in this case it is 1, then that number of valence electrons is the valency. Here the valency is 1. Now, potassium's identity. Potassium is a metal since we know this property that if an element has 1, 2, or 3 number of valence electrons, it is a metal. Potassium is a metal. Finally, our last thing to do. You see, argon, Ar, has a stable configuration of 288. It is the nearest inert gas to potassium. It has a stable EC of 288. To attain the stable EC of 288, potassium loses 1 electron, which is its valence electron in the N shell. That means it again forms the same configuration of stable argon 288. It leaves behind 19 protons in the nucleus, whereas 18 electrons in the shells, creating a positive charge on potassium. K plus cation is formed. I'm giving you a few moments so that you can take a look at all the derivations we got from the electronic configuration of potassium. Here we go. Now we will discuss about calcium. Now let's discuss about the EC of calcium. Calcium, Ca. First, atomic number. Atomic number is 20. Now, AC. is 2A2 KLMN, which means there are 2 electrons in the K shell, 8 in the L shell, 8 in the M shell, and 2 in the N shell. That means number of valence electrons is number of valence electrons, which means number of electrons in the outer shell, which in this case is the N shell, is 2. Therefore, period number is period number is 4, since there are 4 shells, K, L, M, and N. Now, group number. Group number is again number of valence electrons, since it is less than 3. Recall the rule we used to get the derivations in potassium. 2. Now, valency. Valency is also number of valence electrons, since it is less than 5. 2. Now, calcium's identity. Calcium is a metal, since we know the property that if an element has 1, 2, or 3 number of valence electrons, it is a metal. Calcium is a metal. Now, our last thing to do is, argon is the nearest inert gas to calcium, again, Ar, argon, with unstable electron configuration of 288. To attain this stable electron configuration, calcium has to lose 2 electrons, which are the 2 electrons in the outermost shell, that is, the N shell. It loses the 2 electrons and forms the stable electron configuration of argon, or Ar. In doing so, it leaves behind 20 protons in the nucleus, but it has 18 electrons in the shells, which means it develops 2 positive charges on calcium. Ca2 plus cation is formed. Now, you may have a look at all the derivations we got from the EC of calcium. Hope you enjoyed this episode, and please like, share, and subscribe to my channel, and stay tuned for more videos. Thank you.